Hi everyone, welcome back to our design pattern series. Today we are gonna explore the factory design pattern in Java. This pattern is widely used in software development to create object without exposing the instantiation logic to the client. So let's dive into it. So what is factory pattern? So factory pattern is a creational design pattern again that provides an interface for creating objects in a superclass but allows the subclass to alter the type of the object that will be created. This pattern is particularly useful when the exact type of the object to be created is determined at the runtime. We'll see the example. Imagine you have a building system for a transportation company. You might have a different type of vehicle like car, truck, and motorcycles. Instead of creating this vehicle directly in your code, you can use the factory to generate them. This makes your code more modular and easier to manage. So why you use the factory patterns? The factory pattern is beneficial when you have a superclass with multiple subclasses and you need to return one of the subclasses based on the some input. The creation logic might be complex and you want to centralize it. You want to decouple the client code from the object creation code. So let's see the Java code. I'll create a new package and I'll just simply create um, simply vehicle factory or simply. So what I will do simply, first of all, I'll create an interface over here and interface vehicle, and it will have this method called simply drive, and then class car implements the vehicle, and it has the same method. It's just a public void drive and driving a car. Then we have a class called um, bike or a motorcycle, you can say, or then the third one is truck. Okay, vehicle. So we have a three class, one interface, and now let us create a vehicle factory. And what I would say, okay, yeah. So public static vehicle, and then we have a get vehicle method where we'll get the input as a vehicle type, and on the basis of the inputs, we are returning the specific object for a specific either it's a car or bike or truck. All right, very simple code. It's not that much. We have a simply if and else conditions. Now let us create a class called factory demo. Okay, and we will have a main method and in which we have a different factory methods based on the inputs. So vehicle car equal to vehicle factory get vehicle car, the car dot drive. Okay, now let us try to run it and we can get the output. Very simple design pattern. I would say it's the simplest design pattern of all the design pattern. All right. So again, the advantage of the factory pattern is decoupling. The client code is decoupled from the concrete classes. Again, the centralized creation logic, that object creation is centralized to the factory, and the scalability. It is easy to add a new type of vehicle without modifying the client code. Right. Now, let us create. I would just and generate the test method. So vehicle factory test is there, and we can be here. So first of all, we'll write the uh, test, and I would say void test get car. So what is GitHub Copilot returning? Vehicle car equal to vehicle factory get vehicle is car assert not null obviously assert true. The car is instance of this car object. that is a car class. This car object is an instance of this car class. And let's simply print even there. Dot. Simply we are printing. Now let's say, taste the truck or whatever the GitHub Copilot suggests us. It's a bike. And then similar way, truck. Okay. So this is a very similar code. So I'm not going in detail of that. Now, what if with this we have an unknown vehicle? So we can have this kind of test class where exception is only exception throw illegal argument exception get vehicle, then should throw an exception. All right. But in this case, because whatever the uh, uh, we get it, we are just simply returning the null rather than what we should do is throw an exception. So illegal argument exception. Okay, now it okay, and now it should work. So either writing the test, we get to know that this exception should come. So we have just modified this code. Okay. So test writing the test is good practice. Let's see two more test cases. So test get value vehicle, and if it is null, assert null, and if it is blank, it should also return the null. Okay. In here, in this case, it should throw an exception. In fact, yeah. So I'll just remove this test case because we already covered this in an exception kind. Okay, all right. Look pretty good. Let me run all the test cases simultaneously. Okay, we have run executed all the test cases simultaneously, and they are perfectly working fine. All right, so that's it for this video. Thanks for watching. See you in the next video.